Before we get started, give me about 30 seconds to ask for money, not for me, but to help Battleship Texas. Funds for critical repairs are in place, but there are a number of other repairs best performed while in dry dock that still need funding. This is where you can help. Please use one of the links in this video's description to visit Battleship Texas Foundation's website, where you can purchase memorabilia or directly contribute to the effort. When Texas fought for independence, the rally cry written on the battle flag was, "Come and take it." From that springs a new cry to help save her ship, which is, "Come and save it." Whether you are standing next to it on the dry dock or looking at her from across the channel, it's pretty easy to see that the rudder on Battleship Texas is not centered. This has a lot of folks worried, and there have been hundreds of discussions online about the importance and what it would take to center it. Unfortunately, its great size and weight and the condition of its turning gear all conspire to create a project whose cost and manpower requirements makes it prohibitive. This is especially true considering that the rudder is only seen when the ship is out of the water, and the only problem it presents is a minor one while the ship is being towed. All of these conversations made me curious about the rudder's design and construction. I was fortunate because we have builders' record drawings of the rudder and turning gear and descriptions of its operation in period textbooks and manuals. This gave me plenty to work with. Let's start by assembling the rudder. It begins with two large steel castings that make up its structural frame. These are riveted together to form a single rigid piece. Riveted inside of the frame are steel braces that help create the rudder's curved cross-section. The smaller spaces that result are filled with white pine impregnated with pitch, and the remaining cracks between the pieces are filled with red and white lead. All of this creates a strong, well-formed structure that is highly resistant to corrosion and water intrusion. The final act is to cover the assembly with an outer shell of 3/8 inch thick steel plate. The overall result is a strong rudder with impressive overall dimensions of 27.5 feet long by 18 feet tall. What kind of effort does it take to install something this large? In 2 words, a lot. We have photos of part of the process taken while sister ship New York's rudder was being positioned during her construction. We can see that a platform for workers extended beneath the stern, and the completed propeller shafts were covered to protect them. The rudder was brought to the ship using a huge crane and supported by a spreader that separated the lifting cables enough to straddle the stern of the ship. This allowed the crane to bring the rudder up to its final position. Once close, additional blocks and cables were attached to hull-mounted eyes so that it could be precisely maneuvered. Using those, it was carefully aligned as a final step before being attached. Before we get into mounting the rudder, let's take a look at the massive rudder stock that was already installed. It's a combination of a cast bracket that bolted to the rudder and a post that extended up and attached to the steering gear. Installing this piece also required considerable effort. It started by sliding a brass sleeve onto the post and shrinking it in place. The sleeve acted as a bearing surface for the post as it rotated to turn the rudder. As the rudder stock was lifted into place, it had to be tilted to clear the hinge pieces that the rudder mounted to that are called gudgeons. As it slid through a large opening in the hull, it was rotated to a vertical position and lifted as high as possible to provide maximum clearance for the rudder while it was being installed. Let's get back to the rudder. As shown in the photos of New York, it was lifted into place and carefully positioned in the gudgeons. At that point, hinge pins called Pintles were brought up. Before installation, brass sleeves were slid onto them and pinned in place. Once done, the Pintles were installed to fix the rudder to the stern post. The rudder head was then dropped into place and bolted to the rudder using 14 3 3/4 inch bolts and nuts. With the rudder in place, its turning gear was then installed and attached to the post, and rams were attached to largely complete the operation. Included in the assembly were bearing races in the hull opening that provided the turning surfaces and seals that formed the stuffing box to keep water from flooding the steering gear room. Lastly, access openings in the rudder were filled with mutton or beef tallow to protect bolts and pintles from seawater, and covers were screwed into place. One can only imagine the odors that struck dockyard workers who removed the covers and scooped out rotted beef fat when servicing the pintles. The final step of assembly was attaching zinc protectors to the rudder and stern post that acted as sacrificial anodes that reduced corrosion. This brings us to a critical point about the installation and the ship's condition. The stuffing box was intentionally allowed to leak a small amount of water past the rudder post. Why is that? A basic rule when sealing around any rotating shaft that penetrates a hull is if it doesn't leak, it's too tight. Being overly tight may damage the seals and possibly the bearings, making it necessary to put the ship into dry dock to repair them. For that reason, some water was allowed to leak past the stuffing box and shaft. This wasn't a problem when the ship was in service, since they continually pumped the water overboard, but it was a big problem when the ship was retired and donated. It's my understanding that the Navy attempted to permanently seal around the post prior to donation and being moved to her new home. Unfortunately, whatever was done proved to be ineffective. To be fair to those who worked hard to maintain her, this ship needed to be out of the water to properly do the job, which simply was not possible. The result was the steering gear room and adjoining aft steering room flooded over a period of time and suffered significant corrosion. It wasn't until the dry dock session of 1988 through 90 that the problem was permanently solved by filling and welding the opening between the rudder post and hull. The turning gear consists of a screw-type mechanism that was popular in large vessels in the late 1800s and early 20th century. Think of this as two screw jacks that have been placed on their sides and hooked together to operate in opposite directions when the screw is turned. These are hooked to rams whose opposite ends are hinged to a bell crank called a crosshead that turns the rudder post and rudder. As the incoming steerage shaft rotates, it turns the power pinion that in turn rotates the gear wheel and main screw. There are two sets of threads on the wheel that have opposing pitches. These make the two rams move opposite from one another and apply equal force to both ends of the crosshead. As the crosshead rotates, so does the rudder. The result is a rudder that can swing 35 degrees in either direction for a total of 70 degrees. Not only can the gear move the rudder its full travel in only 20 seconds, it can do so against hundreds of tons of force created by water as the ship moves at its top speed of 20 knots. As you can see, the rudder and its turning gear are both incredibly large and durable, but time has taken a toll. Any effort to center it would require freeing the pintles, grinding away the welds between the hull and rudder post, and somehow getting access to the bearing sleeve on the rudder stock to free it. The rams could then be detached and perhaps rudder turned by forcing it from below with the hope that it's still structurally sound enough to survive the effort. Not only would the effort likely turn into a money pit, the possibility of irreparable damage to this historic artifact is simply too great to risk. So there you have it, some insight into this marvelous piece of engineering and design, and my humble opinion regarding the danger of trying to correct a problem that really isn't a problem. Again, please help with the effort to maintain Battleship Texas as the world's last surviving dreadnought and proud survivor of 2 world wars. Use the links in this video's description to purchase collector's items and gifts or donate money. Every dollar counts. Come on, Texas!